Hello, welcome to the latest episode of Data Unchained. I'm your host, Molly Presley. Let me tell you a little bit about what the podcast is focused on. The whole paradigm for data access has changed over the last couple of decades, really. We've had the advent of the cloud. We've moved to a lot of SaaS-based tools. Remote workforces became more common in COVID. And applications and data are often distributed from or decentralized from each other. Data Unchained digs into both the challenges as well as the solutions that make data an asset as a global resource. Today's guest, Marcello Molinaro, is, I almost got that right. I have to always avoid my Spanish touch to how I speak. But Marcello Molinaro is a data analyst at Mozart Data. And Marcello, first, just thank you so much for taking the time to join us.
Thank you so much. I'm happy to be here.
Tell us a little bit about your background, both personally and professionally. How did you end out where you are today?
Yeah, so I've been working in data and data infrastructure for about the last 5 years, most recently with more of a focus on the, quote, modern data stack, which I'm happy to get into a little bit later. I started as a practitioner working for first a travel company and now with Mozart Data, helping customers and companies do all sorts of different things. So answer business-related questions, build dashboards, model data, kind of anything that they needed. And currently now with Mozart Data, we help customers do that by providing infrastructure for them. So an out-of-the-box solution for the modern data stack so they can focus on answering questions instead of building infrastructure.
So that's different than what most companies are doing. It seems like everything's as a service. Everything is get your data up to, Databricks or Snowflake or something in the cloud. Can you go a little deeper into what is in the box, so to speak?
Yeah, definitely. So in the box is some tools that you might already know. So we leverage Fivetran and Snowflake, like you mentioned, Molly, in addition to our own transformation layer, making up the ELT of the modern data stack. So Fivetran is the extraction, a best-in-class service. Snowflake is the data warehousing and compute layer. And then we offer a transformation layer that customers can use in addition to existing transformation layers like dbt. So you can kind of pick and choose. It's your box, so you can choose what you want to do with it. But we have opinions on what we think is best and easiest for our customers getting out and getting started, so they don't have to make these tough decisions cost-wise and effort-wise to set up. Then at the end of it, you plug in whatever BI tool you want, or reverse ETL if you care to do that too. And you're off and running with your business insights.
I saw a graphic from Gartner the other day. I was on an analyst call with one of them, and they have a picture of what people want an analytics workflow to look like, and had a picture of a car, like a Lamborghini or something awesome. And then they had but really what it's like to implement. It was essentially like a big grocery sack full of parts, everything from the transmission to the cables to the tires. And it sounds like you are addressing the need for getting to what people want instead of piecing and parting together the really complex workflow.
Exactly. Yeah.
Very cool.
It's something that I think young companies starting out struggle with, thinking that they need to build these tools. They need to build their own like SQL editor, or they need to build, have to host their own warehouse. And it's actually something that lends itself really well to another company owning and managing that service, especially if the other company can do it cost effectively.
Very cool. And then a little bit more about your background. I know I jumped right into what Mozart Data does.
Yeah, I come from maybe a somewhat unconventional place. I studied environmental science in undergrad, and I've actually worked a lot in customer service. And I don't know, I might think, or I might have thought those don't lend themselves that well to the data space, but I've actually found environmental sciences, we're often looking at the big picture and then honing in on really small specifics. So maybe we're talking about landscape ecology, and a fire rolls through a landscape, and you want to know, okay, why did this fire burn in different ways? Why is it patchy here and very intense and destructive over there? And that requires like zooming in and drilling down into what we would call in data, like the business problem, and really focusing on, okay, what is the species composition? What is the age composition? How does the soil moisture and the microclimate relate to this problem? Which is something in data we want to know. You want to say, okay, are our growth marketing efforts being successful? Okay, let's focus in on different campaigns we're running, who are our audiences, etc. And then the customer service element, I thought it wouldn't apply too much in business, but whether you're working with internal stakeholders or external stakeholders, it's always important to put the customer first and try and understand their problem and hear them out, where they're coming from, whether it's your CEO, whether it's your peer, whether it's the customer you're working with. And sometimes the question that they want answered isn't the question they need answered. And so working with them to try and understand what their needs are and why they think they want what they want. And sometimes they're right and sometimes they're not. And finding a solution to that with a customer-focused response often lends itself to kind of the best solutions where everybody's working towards the same solution rather than a little being combative on what you think the best solution is.
I find it interesting that as I've watched the job of a data scientist evolve in a company from the first one who came into an organization I was in that I didn't really have a clue what the person was doing to now, they're this hot commodity that are just, something you absolutely need in your company. I do think it's interesting that often business people know how they want to run their business and data science people know how to extract information, but how those two intersect with is the data science team pulling the right information and answering the question that people want to answer versus just interesting insights. And then the execs or business team maybe who are not asking the question that's most relevant. How do you do that? So if you were to give advice to folks in this role, how do you facilitate that conversation in your organization? How do you maybe make people open to a broader answer than maybe what they specifically asked for?
Yeah, it's difficult. So it requires having a lot of compassion and meeting people where they are. Something that we talk about a lot is that analysts, data engineers, analytics engineers, and then to an extent data scientists and analysts on the end of that tend to think left to right. So when I'm building something, I'm thinking, okay, what are our data sources? What's the raw data look like? How do we transform this, clean and organize this data, combine it with other data sources that we have? And then how do we visualize it or manipulate it? How do we model it, put it in a dashboard or, run some regressions on it to try and determine what it is we want, a predictive model, a table with all the answers. And the business people tend to think right to left. They're like, okay, we have this problem. We need more customers or retention's terrible or, whatever. And they're like, we want the answer. We want to know what features of our product are most effective at retaining customers. And so meeting them in the middle there and saying, okay, here's like, sometimes it's as simple as sitting down with a Google Sheet and saying, okay, what are in this, whatever final answer you want, what are the rows and the columns that you need? What does each row represent? Okay, in this situation, each row represents a customer's visit. And then going through column by column and saying, okay, what are the features or what are the columns that you think might contribute to this? Because in the end, the business stakeholders, they tend to understand the business better than the scientists, better than the analysts. And the data scientists and the data analysts are specialized at kind of bridging that gap. But they know, okay, we actually don't care about, if it's a grocery delivery service, we don't care about number of days it takes to return. We just care about whether or not it was returned, and we care about what was in the return. And that kind of process where we're sitting down and we're creating something together really tends to bridge the gap I found in bringing the left to right and the right to left together in a way that can allow people, okay, so the business owners see, oh, I see, like, we can't just say we need this answer. We need to help them build this table. Like a table needs to be built to be able to either ingest it in a model or build a dashboard with it. And the analysts or data scientists understand, okay, this problem is actually a little more complex than we thought. This is the additional context we need to help answer it.
Okay, that's super interesting and a great way for us to think about, we all think about left brain, right brain thinkers, and you take that a little bit even further on kind of the way the linearity of thinking works for different folks. That's really interesting. So you can't open a newspaper or magazine or anything today and not see things about AI. That's not new. Data analytics has been around for a while. You're a data scientist. Can you share what's the difference between data analytics and data science, and kind of how do you bridge between the two?
Yeah. How do we bridge the gap between data analytics and data science? So I think first is understanding that a lot of what is required for machine learning and AI, which has become very popular now, but has been going on for a long time. What I would call more of the data engineering side of things is understanding that it starts with good data. Maybe you've heard garbage in, garbage out. And a lot of a data scientist's job is cleaning data. I don't know if you've seen that there's like a meme about what people think data scientists do, and it's like a big brain doing a lot of neurons firing all at once, and then the other side of what it is they actually do, and it's just a list of 100 different ways to misspell Philadelphia. And so much of our time as data scientists is spent cleaning data. Because if you want to know what are the metrics that most impact the sales in Philadelphia, you need to have one truth of what is the city of Philadelphia. So it starts there. It starts by cleaning data, and then I think in order for a business to really succeed with what I would call these more technical types of analysis is really understanding how it's going to be used and why. So sometimes companies will run experiments. They'll say, okay, we want a predictive model on retention, and they won't have a set idea of what it is they're going to do with that. So if they get a model that doesn't have anything, it says, okay, none of these features actually predict retention very well. Versus, okay, we found this one feature that does predicts retention really well. Well, then what are we going to do with it? And if we get no results, are we going to treat that the same way? Kind of coming at AI and data science and machine learning from a very experimental point of view, I found can be very helpful, rather than coming at it from maybe a revenue forward point of view and saying, okay, we're hyper focused on increasing revenue, and we're going to do whatever it takes. And we're kind of going to ignore anything that isn't good. We're going to ignore anything that maybe doesn't reflect our opinion of the truth of what it should be. It actually tends to degrade the data scientist's work when they're saying, hey, we did all this work and we actually didn't find there were no results. And that in itself is a result, right? Like, doing a lot of work and saying, hey, these 100 features, we couldn't find anything that really predicts the thing we're looking for. That's good to know. That's helpful information. So maybe what you're looking for isn't where you were looking, and you have to look somewhere else and try something new.
Yeah, that's a great way to look at, and I look at the workload that you have, but also I'm curious, is it getting more difficult as more data is being generated, as the locality of data is different? Do you feel like that has become just an exasperating issue, is where to even find your data sources?
Yeah, we do see that, especially at Mozart, where we're exposed to a lot of different customers who have a lot of different data sources. And it can be hard. You can have, 4 or 5 different SaaS tools that you're working with, and all of the data is in different places, and you want to analyze it all together. We actually run into that a lot. Even at Mozart ourselves, we use Mozart for Mozart. So, like, take Salesforce and Stripe data, for example. You've got all of your CRM in Salesforce and all this information about your customers, but you invoice them in Stripe. And you want to know, are we invoicing our customers what we think we should be invoicing them for? So we've got our expected revenue in Salesforce in our opportunities, and then we've got our invoices in Stripe. Well, how do you compare the expected revenue versus the actual revenue? Mozart actually is a good way to do that in any sort of cloud data warehouse with a good extraction tool on the end. can help you fix that. So you can bring it all into one place. You can consolidate it. You can then model it the same way. So you've got the same columns, the same rows, and then you can bring it into your dashboard and you can chart expected revenue versus actual revenue. Another issue that we found is the long tail of data sources can be really challenging. So sure, Fivetran supports Salesforce and Stripe, but then so does Stitch and all of these other Airflow and these other extraction tools. But what about you're a restaurant business and you want your point of sales being brought in, or you're a direct to consumer service and you use this one niche software and you want the data from that. You've got access to it in the service, but you can't bring it into your data warehouse easily. There are some other tools like we leverage Portable that services these long tail connectors, helping companies that have 17, 20 different data sources bring all of them into one place so that they can then model the data and organize it and then analyze it together.
Excellent. And I'm curious, your work at Mozart Data, I'm trying to distill this out in my head. Are you helping build this infrastructure toolkit, or are you doing data science yourself? Is it a service that you're offering? What is the product of your work as a data scientist there?
Yeah, so we do both. So first and foremost, Mozart is the infrastructure. It's an easy way to, when you sign up for Mozart, you get a Snowflake data warehouse, and you get a Fivetran account, in addition to some other tools. And we make it really easy for you to go and connect to your Salesforce and connect to your Stripe and connect to your point of service tool and bring all that data into Mozart. Some companies have data teams, and so they don't need a ton of help modeling and then analyzing their data. And other companies are starting out. We do focus a lot on startups who maybe just have one analyst, or maybe it's the head of growth or operations who might not know a ton of SQL, might not be familiar with modeling techniques. And that's where we can step in and help them out and say, okay, tell us about your business problems. Let's think about this. This is how we'd model it. And this is the Python packages we'd use to run some analysis on.
Okay, so you kind of sort through the problem, and then as you're looking at how you architect or pull the data, how do you approach that?
Yeah, it starts with the problem. So understanding, is this a one-off, or is this something they're going to want recurring? Mozart is called Mozart because we orchestrate your data pipelines. So the best use case is to set it and forget it. So say you've got you run a franchise, a restaurant, and you've got seasonal workers, you've got part-time workers coming through all the time, and so you've got a lot of turnover. And you assign different fields, different characteristics to these people, and it's really important that you flag when you've input it wrong. So for this problem, we think, okay, so here's the table that we think you need. We'll schedule this to run whenever your data comes in. So maybe you've got new data every day, or maybe you do new payroll every week. Then we build a data model that's going to be able to represent these characteristics. Maybe it's the part-time flag. Maybe it's whatever else it could be, and then run a query on that table to identify when something's off. Set an alert so you get an email or you get a Slack message when that happens. And so your data infrastructure is taken care of. All you have to care about is the problem. And then when the alert pops up, you say, oh, it looks like we entered this wrong. You go check your payroll system or whatever it might be. And then you're good. You don't have to worry about your cron jobs. You don't have to worry about your Python script and package updates. You don't have to worry about the extraction or the SQL that you've written. Set it and forget it, and the modeling's all done for you.
And how do you present your results?
Yeah, it, again, depends on the problem. So some companies are using different BI tools, and some people just want them in Google Sheets. If it's often, we find the finance teams and operation teams might prefer a Google Sheet. They say, just show me the data. Sure. I just want to see the data.
Yeah, sure. Yeah.
And so Mozart is able to take a data model you've created and send it right to a Google Sheet. So I found that's the most helpful. We're on a weekly call with a customer, and they wanted all of their sales leads for a certain area, and they've been doing this complex process in some BI tool in the past. And we say we can model that for you with SQL with pretty basic transform, and then we can just pop it in a Google Sheet, and whenever the transform runs. And doing it with them tends to be really helpful. So they see, okay, maybe I don't understand the SQL that you wrote, but I understand the Google Sheet with all the data, the rows that we expected and the columns we expected.
Exactly,
You press the button, it runs, and it pops out, and that can be pretty helpful for people. It's a tool I always wanted as an analyst, because as much
absolutely.
as much as people want a dashboard, sometimes they just want to see the data in a CSV or a Google Sheet,
and then they can deduce what they want to deduce. But if they want it in something like an output from Tableau or something like that, that's fine too. It just depends on what your customer's looking for.
Yeah.
Makes sense. I'm curious, as we start to tie things up, I think that this is such an interesting field that people would like to get into. There was some discussion of a surplus of data scientists because a bunch of tech companies did layoffs and whatnot. But then on the other hand, the number of data-driven projects has grown so much faster. And, the number of tools and the applications, every day are accelerating. And so I think this is such a great spot for people to be getting into. How would you recommend it? You came a non-traditional path, but do people need formal education? Can they learn on the job? What do you recommend?
That's such a good question, Molly. I was actually just talking about that to a friend yesterday. I think because it requires so much interacting with other stakeholders, I think coming from non-traditional backgrounds is actually a plus. Personally, at my first job, I was using online courses to learn a little bit about data science. The classic example is data science is math, statistics, and computer science, all combined with a business logic. So you have to be at the intersection of all those things, and you don't have to be an expert in any one of those, as long as you're willing to learn. So there's so many online courses. There's paid courses, there's free courses that you can take to learn SQL, to learn Python, to learn about database management. And then I would just say there's so much data out there in so many different areas. Go do your own projects. Make a project, build a dashboard. There's so many free tools or free versions of business intelligence tools that you can use. Tableau, for example, offers a free version, and I'm sure a bunch of other ones do as well. Build a project on GitHub and share it. Post it on your social media. Just show that you took a question that you had, which is what any analyst at any company is doing, right? And show that you can apply whatever business logic you think applies to the situation and your analytic mindset, and you can present something that someone would care about, a why and why it matters.
And I kind of know the answer to this, but I want to talk about it a little bit. And what about data sets? I think it's fair to say there's a lot of data sets out there and projects you can use for interesting analytics. But could you talk a little bit about that as well?
Yeah. Again, start with something that you care about, but the government, the United States government, has a ton of data sets available. I was just looking at, I went swimming in a river in central Northern California this weekend, and I was interested in, it felt cold and it felt high, and I was interested in understanding how cold and how much higher was the river than when I was last there. And I was looking into, does this data exist? And the USGS publishes data daily on this river on temperature. And California Department, it might have been Department of, I can't remember, Department of Streams, but it was pretty easy with the Google Sheet. Shows the CFS flow. So I was able to get the data in 10 minutes, download it into a CSV, and then go from there. And if you can get something in a CSV, you can do anything with it. You can start your own SQLite database, or you can, port it into Tableau or Metabase, a free BI tool to visualize however you want. You can use R, you can use Python, all of these free tools. to get access to data that just relates to a question you might have.
I'm a whitewater kayaker, and I'm familiar with similar sites that talk about the cubic feet per second of water that's going through a certain run or a certain rapid. And I've always just had to go look and try to figure out what's normal versus not, and is it safe? But it sounds like next time I should call you and ask you, is this a safe water level or not? You could do it so much better than me.
Maybe,
I love it.
maybe.
This has been a great conversation, and I really find it interesting for our audience to learn about not just what can be done with data science and analytics, but some of the ways to make it easier to implement in their organization. So having the opportunity to share a little bit about the approach with Mozart Data is great. Can you tell me just what's the best way if somebody was listening to the show and wants to get in contact with Mozart Data? I assume calling you is not the right answer. There's probably a better place for learning more or sales. Where would you recommend they reach out?
Yeah, you can actually go to mozartdata.com and sign up for a demo. We offer a free trial. And actually, it's free forever, depending on how much you use. So you can go and check out the project, sign up for a demo, and connect some of your data sources. And if you've got some of the we call the standard data sources, you can bring your data in and immediately start transforming it. And then, of course, you can, if you want to talk to a salesperson, you can, and they'd be happy to answer your calls. But if you are a data person or, someone in leadership that wants to play around with your data and see how it works, you can do it without talking to anyone. But of course, our salespeople want to get involved too.
That's a great way to get started. As a marketing person, we talk about data-driven organizations a lot. And I think sometimes that just become a term people are used to hearing, but there's a lot more to it than that. Why is it important? And in your world, what does that really mean?
Yeah, I think being data-driven has kind of become a buzzword for organizations and departments within organizations. And I do still think it's quite important. But personally, I think data-driven means using data to reduce your biases. So we all have biases in different ways. Maybe it's towards our marketing department, maybe it's towards the finance team, or maybe it's just personal. And I think leveraging the data we have, data is biased too, right? There's all sorts of biases inherent in how we collect data and which data we choose to collect and so on and so forth. But by acknowledging that and saying, hey, we know the data is biased in X, Y, or Z, but we're going to choose to make this decision based off of what we see, reduces that kind of going on your gut, which is essential for small businesses. But as you grow and scale, I think being able to defend and support the decisions you're making with reason, with logic, and with data can be really powerful and allows other people to trust in you, which I think is really important.
You hear the word in this space, the word bias, quite a lot. And when you're thinking about removing biases, acknowledging them, maybe finding an unbiased data set, where does that actually happen? Does it have to happen at every step of the way? Or is it, at the end, you then acknowledge what was there and design forward? How does that work?
Yeah, I'm sure there's tons of different ways to deal with this problem, and none of them are perfect. I don't know if you've ever been in a meeting with a data scientist or an analyst, and they say, okay, here's the data we're presenting. This is the chart. But I want you to remember that 1, this excludes these types of customers. 2, this was only done over a 3-week period. And 3, X, Y, or Z. And it's the analysts and the data scientists that know that here's the experiment we ran, and we ran it in this type of vacuum. And it's specific to this situation. And they tend to have the context required for that they then pass on. And what's interesting about that, I think, is some people think that an analyst in that situation, for example, is just trying to cover their butt, for lack of a better word. But really, what I think is happening is that a lot of that, we can call it like bias mitigation, is happening at the analyst level. So it's happening in SQL, or it's happening in the data engineering process that no one else sees. And I think they're just calling it out. Like if you add a filter in SQL, you add a where customer is not equal to X, I want someone to know that I did that. Like, I think it's important. I excluded those customers for some reason. Maybe they're churned, or maybe, whatever. They've got some characteristic that doesn't apply to the situation. But it's a decision that I made that has business context, that I think other people need to know about. And so listening to the analysts and data scientists when they are explaining that, talking about their caveats, and then going forward and saying, okay, we understand that this analysis excludes this, or it has this characteristic, and we're going to choose to move forward based on that. Actually, that's kind of important to us, and we didn't know you were excluding, people from that region or whatever. Let's go back to the drawing board and figure out, okay, if you were missing data, how can we get you data to address those people? Something like that.
Marcello, thank you so much for joining us today. It's been a really interesting conversation, and I know you're probably quite busy, so thank you for taking the time.
Thank you so much, Molly. It was a pleasure.
Thanks for listening to Data Unchained, powered by Hammerspace. To learn more, visit hammerspace.com. If you have a guest you would like to hear on the show, email me at molly@hammerspace.com.